In this problem, we're going to look at some context in regard to completing the square. So we're going to complete the square with this equation and figure out what's the maximum height of the rocket, find the minimum time the rocket's in the air, and the solutions. So we're going to start by writing the equation. So I get negative 16t squared plus 40t is equal to 0. And I want to factor out the negative 16 because I need an a value to be 1 while I'm completing the square. And so that's going to give me 40 divided by negative 16. So I want to simplify that. And negative 40 sixteenths are both divisible by 8. So that'd be negative 5 halves. So I've got negative 16 t squared minus 5 halves t equals 0. And then remember what you want to do is you want to take your b value, which is negative 5 halves. It's okay that it's negative. You're going to take half of it, and that's going to give you negative 5 fourths, which then negative 5 fourths you want to square to give you 25 sixteenths. So I'm going to add 25 sixteenths here. But what am I going to add to the other side? Well, it's not 25 sixteenths. Remember, it's negative 16 times this. So negative 16 times 25 sixteenths would be negative 25. So now I want to go ahead and write this as a perfect square trinomial. So I get t squared minus square root of this term, which would be 5 fourths, quantity square equals negative 25. Now remember, I could go from here, I could solve, which I will get to that point, but I want to go this direction and find the vertex form. So all that's going to entail is adding the 25 to the other side. So I get negative 16 t squared minus 5 fourths quantity square plus 25 equal 0. And remember, you can type this into your calculator and check, but the vertex will be, remember this is, don't need the, apologize for that, don't need the t squared there or there, got ahead of myself. That's just going to be t, and that's going to be t minus. So remember, the vertex is in that form a x minus h quantity square. Well, h in this case, notice h is going to be a positive number. So it's t minus 5 fourths, so that means h was a positive number, and y, or k, was a positive number. So the vertex of this quadratic that models an object being launched 40 feet per second has a vertex of 5 fourths, 25, which would make the axis of symmetry to be x equal 5 fourths. It's always the x part of your vertex. So, to solve it, negative 16 t minus 5 fourths quantity square equals negative 25. So I want to divide by negative 16, and I get t minus 5 fourths quantity square equals 25 sixteenths. And remember, in order to get to this t value, I want to square root both sides. That's going to create a plus and minus. So this is 5 fourths, and this is t minus 5 fourths. So I've got t minus 5 fourths equals 5 fourths, and t minus 5 fourths equals a negative 5/4. So when you add the 5/4 over, you get x equal 10/4, or x is equal to 5/2. So 5/2, comma 0. And we write that a little better. So that will be 5/2, comma 0. And this one would be adding 5/4. So I get t equals 5/4 plus a negative 5/4, I get 0. So it'd be 0, 0 as the solutions. So find the maximum height of the rocket. That is the vertex. So what's the maximum height of the rocket? At about 1 in 2,500 seconds, we're at 25 feet. So 25 feet. Find the maximum time the rocket's in the air. The maximum time the rocket's in the air will not be the vertex. It will be how long that rocket stayed in the air and then hit the ground, which would be one of the solutions. And we notice that it would be about 2.5 seconds for the rocket to stay in the air. And when does the object hit the ground? It would be 0, 0, and 2.5, comma 0.